today is May 4th, Monday, and we're going to finish lesson 7.5, which is Pythagorean theorem, converse, and distance formula. So we are going to work on the distance formula today. I'm going to show you how to find the distance between points using the Pythagorean theorem and then the distance formula. The distance formula you're going to probably find easier, especially if you don't have graph paper at home. But I'm going to show you how to use a graph just in case. So first of all, you're going to be given 2 points. I'm going to graph them. Okay, this is 1, 5. And then I'm going to use 1, 2, 3, 4 to the left, 2 down. This is -4, 2. Okay, now I'm going to connect the points. I'm trying to find the distance between these 2 points. Okay. Now, as you can see, this is a diagonal line. So I cannot count the boxes to see how long the line is. You can easily find the distance between 2 points on a horizontal line. You would simply count the boxes. This is 4 long. I can easily find the distance between 2 points on a vertical line. 1, 2, 3. Easy. The problem is you can't find the distance on a diagonal line. So what I'm going to do is I'm going to simply connect vertically, horizontally, and now I created a right triangle. So now you can easily find the distance between these 2 points by using the Pythagorean theorem. So I can count 1, 2, 3, 4, 5, 6, 7 here, and I can count 1, 2, 3, 4, 5 here. Okay, so I'm going to call A 5, B 7, and C is going to be the distance between these 2 points. Okay, so using the Pythagorean theorem, I'm going to do 5 squared, which is 25. I'm going to do 7 squared, which is 49. That's going to give me C squared. And when I add 25 and 49, I get 74. And, you know, the last step in the Pythagorean theorem is to take the square root. So I'm going to get C equals the square root of 74. Now, the difference between distance and the Pythagorean theorem, we're usually going to leave the answer as a root for the distance of a line because distance cannot be an irrational number. So basically, the square root of 74, which is a number between 8 and 9, is the distance of this line. Okay, so if it says to solve and round, you will solve, but for most of the problems in the classwork, you are going to leave your answer as a square root when you enter it. The square root of 74 is about 8.6. Okay, remember this is an irrational number because there is no square root of 74. You're only going to take the square root if you can, and you can't take the square root of 74. So this distance between these 2 points is approximately 8.6 squares or units. And so we estimate the distance to be 8.6. The exact distance is square root of 74. That is using the Pythagorean theorem. You must have graph paper to do it this way. Now I'm going to show you what I think you're going to find is an easier way to do this, which is finding the distance between the 2 points using the distance formula. Okay, so first of all, if you want to pause right now and go get your textbook, you can. And here we are. Okay, so I'm on page 320. You want to copy the distance formula into your notebook. Okay, give you a second to do that. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? We're on page 320. I'm going to go over this example, which is the one I just did using the Pythagorean theorem, and I'm now using the distance formula. Same problem I just did. Okay, remember you can graph it if you want to. You're probably going to find it easier to do this way. Just showing you that you can do it both ways. So the points that we started with were 1, 5, and -4, -2. Okay, step 1. You're going to want to write down which is your x1, y1, x2, y2. So we have the first x coordinate. This is kind of like slope. So let me go back to the distance formula for 1 second. Sometimes the students get confused with distance formula because they think of slope, okay? So I could find the slope of this line, which would be rise over run. We actually would just take these two numbers, whatever the answer is here, and put it over the answer here. That would give you your slope. We're not finding slope, we're finding how long the line is, okay? So don't get confused between this and slope. It's similar where you're finding the x2 and x1, but you're finding the distance, not the slope, okay? So let me go back to the problem here. Okay, so first, just like with slope, we're going to identify our points. So I'm going to do x1. This is my first x coordinate. And this is my first y coordinate. So we got x1, y1. Second, x2, y2. Okay, that's about the hardest part. Is all you have to do is just write underneath your 2 points, x1, y1 for the first set of points, x2, y2 for the second set. Now the rest of it is real easy. You're just going to plug it into the formula. So you have the formula written down, hopefully from your notes. It's on page 320. And I'm going to plug in. So I'm going to do x2, negative 4, minus x1, 1, squared, plus, you're going to add them. Just like, it's kind of like Pythagorean theorem. You'll see that it's close to the Pythagorean theorem. Okay, and then you have y2 minus y1 squared. Okay, now the next step, just going to simplify. This is negative 4 minus 1 is negative 5 squared, plus negative 2 minus 5 is negative 7 squared, and you're going to keep that square root on top. Last step, you're going to square both numbers. Now remember, when you square a negative number, it always comes out positive. That's important to remember. So we have 25, taking the square root. Okay, that's the distance. So you're going to write equals d. And the last step is just to simplify. 25 plus 49 is 74. Remember, you're going to write your answers as a square root unless it tells you otherwise. I believe every question on the assignment today, you're going to leave the answer like this as a square root. So do that. Okay, and now we're going to try another problem just to make sure everybody understands. This problem is probably in your classwork, so you'll have an example here that you can work with. Okay, so I'm going to do number 16. Okay. Okay, so we have 12, 5. This is in your textbook on page 322. Negative 12, negative 2. Okay? So, step 1. This is the problem. You're going to probably have this problem in your classwork today. All right, x1, y1, x2, y2. First x coordinate, first y coordinate. Second x coordinate, second y coordinate. Step 2, make sure you have this formula written down in front of you. I'm just going to plug everything in. So you got d equals square root of x2, negative 12, plus y2, negative 2, okay, negative 12 minus 12, negative 24 squared, plus negative 2 minus 5 is negative 7 squared. And put the square root on top. Remember, your answer is going to be left as a square root. Okay, so I'm going to do negative 24 squared plus negative 7 squared. So it should be, remember your answers are positive because a negative times a negative is 625. Okay, so if you do negative 24 squared plus negative 7 squared, you can put that in your calculator. Remember, whenever you square a negative, it turns positive. You get square root of 625. Now, this is a perfect square. Okay, so what you want to do is check and make sure, because if it is a perfect square, you can actually simplify it. So you're going to do square root of 625. I know that's 25, but in case you don't know, it is 25. So the distance between these 2 points on the coordinate plane is 25 units. Now, like I said, usually your answers are going to come out as irrational numbers. So if you cannot take the square root of the number, you don't take it. Here you can actually take the square root, so your answer is going to be 25. Okay, if you understand it now and you want to try a couple on your own, you can stop the video. I'm going to do one more problem just in case anyone needs that. Okay, so if you understand, you can go ahead and try some of your classwork.